Looking at 2014's number 6, this is a pretty common question. You probably won't see all of these parts to it this year just because there's only 2 questions this year in 2020. But here we're given a differential equation. This is our dy dx. So this is our equation that they came up with this slope field for. So plugging in all those points, getting all these slopes here, and then drawing them in. This is our slope field. So it's given to us this time. A lot of times we have to calculate the slopes and draw it in ourselves. But with this one, they want you to sketch a solution curve that goes through the point 0, 1. So all you have to do for part A is plot a point at 0, 1. That's your first step. And then you just kind of follow this like you're a fish in the ocean or in the stream or whatever here. So you should follow these slopes pretty closely. I'm not great on my slate with this, so mine might be a little bit not as great as yours, but that should be pretty close. Okay, and I was watching a recording of, oh shoot, this should be steeper. Okay, but I was watching a recording of AP that said people spend way too much time on this. Okay, it should just be nice and quick, so I'm sure they're not super critical as long as you're following those slopes pretty closely. Okay, so yeah, we got our dy dx. We did part A already, sketch a solution curve, and then let y equals f of x be the particular solution with this initial condition. So they're giving us the initial condition up in the intro. Sometimes they'll give it to us like within part of the problem, so sometimes you miss it. That's why I underline it. So the function f is defined for all real numbers. So for part A, that's all we have to do. So the solution curve looks pretty close. We should get our point there for the solution curve. Okay, then part B, I might do the work up here. It says write an equation for the line tangent. Whenever it says that, write an equation for the line tangent. You want point and slope. So let's see here. Given in part A, at the point 0, 1, so the point 0, 1, use the equation to approximate. So after this, we're going to find what f of 0.2 is. Okay, so I don't want to forget to do that. So to find the slope, you're just using your dy dx. Slope is your derivative. And we're finding it at the point 0, 1. So this is how I denote that. So in the parentheses, we have 3 minus y, which is 1. And then we have cosine of x, and our x is 0 here. So that would be 2. Cosine of 0 is 1, so just 2. So then we want to come up with the equation before we actually approximate this. Shift it down just a little bit. Okay, so we do y minus the y value equals the slope, x minus the x value. And even if it's a 0, I just write it in because of habit here. So if I'm trying to get y by itself, because that'll serve us a little bit better here, I never do anything with this. I always just leave it as the minus whatever. I don't distribute or anything, because typically when they tell you to plug something in, it plugs in pretty nicely. Now obviously it's a 0, so maybe I will get rid of it this time, but you can just leave it like this. If that's a different number like x minus 1, you just leave x minus 1 in there, and then you need to add this one on over to this side. So this is my y equals, plugging in 0.2, I get 2 times 0.2 minus 0 plus 1, and I can circle that for my answer. I don't want to mess it up by, making a weird error here. Obviously, you have your calculator. 2 times 0.2 would be 0.4, so we get 1.4. We can check our answer here. So 1.4 looks good. So the approximation, and then the tangent line equation. So having this equation. Now, do you have to have it in y equals mx plus b form? No. Okay, so they always typically save like 5 or 6 points for this part C type question. So if it's on there, it's a lot of points. I don't know if it'll be on there this year. It's really hard to tell. So here we're given, find y equals f of x, the particular solution with this initial condition. So this is our initial condition. They did tell me it again. It was up in the intro, so I was nervous they wouldn't. I'm going to start with my dy dx that they're giving me here. So my dy dx is 3 minus y times cosine of x. And this is where we're trying to get our x's. with our dx and our y's with our dy. So typically I'll multiply the dx over first. I want to keep the cosine of x with the dx. And then I want to get this to the other side, so I'm going to divide by the 3 minus y. So what I end up with is 1 over 3 minus y dy equals the cosine of x dx. And just separating the variables correctly will get you that first point. If you don't separate them correctly, you're going to get 0 points. So you can do a lot of work from here to the answer and get 0 points for it if you mess this first step up. So take a moment to get that right. Then we're going to integrate, and a lot of times you'll get a point for this antiderivative and a point for this antiderivative. So antiderivative of cosine, sine, and I put my plus c with my right hand side, my x typically. And then over here, this is linear. If it's linear in the denominator, it's the natural log of the absolute value. So we got natural log absolute value of 3 minus y. Now this one here is linear with a slope that's -1. So you have to do 1 over the slope out front. So if this was like 3 plus 2y, you'd have 1/2 out front because you do 1 over the slope out front. It's like a u substitution, but doing a u substitution is such a pain, especially in a problem like this one. You want to just keep moving to get through the problem. So this is where we're at now. So I'm just going to write that as a negative natural log absolute value of 3 minus y equals sine of x plus c. And I would multiply everything by a negative. And I just switch it to a minus c. You could switch it to a new constant letter if you want to do. Some people say you can even leave it as a plus c. They probably wouldn't mark off there. And then we're going to exponentiate both sides. So go e to this power equals e to that power because the e and the natural log go away. And we've got the absolute value of 3 minus y equals. And this is where we have to be careful. It's e to the negative sine of x. And the minus c is up here. That's the same thing as doing times e to the negative c. And this is just a new constant. It's e to a number. A number to a number is just a number. So the way we write this then is with a new letter. Usually I think we use a or k. Different books use different things. That's this here that we're timesing by. It's a new constant. And then we have e to the negative sine of x. This a absorbs that plus or minus piece of that, so we just have 3 minus y. And then they're going to want you to solve for y, but they're also going to want you to solve for this like c value, which is now an a value. So it's up to you if you want to do it now or later. I suppose we can just finish this out. So I'm going to subtract the 3 over. And then I'm going to go ahead and switch these by multiplying everything, whoops, by -1. So now I've got my y equals equation. Let me just shift this so I can finish this off to the side here. Okay, so now I've got my y equals negative a e to the negative sine of x plus 3. And then I'm going to plug in my x is 0, my y is 1 to solve for my a. Okay, so this is going to be the sine of 0, which is 0. I'm going to subtract the 3 over, so I'm going to get -2. Anything to the 0 power is 1, so that just goes away, so my a is 2. And then you got to be careful that you put a being 2 here, so we have y equals negative a, so -2 e to the negative sine of x, and then plus 3. And hopefully we didn't make an error. If we did, we'll correct it here. Okay, so -2e, okay, -2e to the negative sine of x plus 3. So we got to the right equation here. So first point, separation of variables. So getting here gets me 1 point. Antiderivatives, 2 points. So antiderivative point here, I bet a lot of people miss that negative. You should still get your antiderivative point there. But it says here, note, max of 3 out of 6. If no so if you forget the plus c, they're not going to give you any more points. So we got our plus c. You can solve your c at this point if you want to, which maybe you did. You should still end up with the same answer, obviously, here at the end. So it's fine if you solve for the c now or if you solve for it later. But constant of integration, having the plus c, then, so just putting the plus c this time, when it's 6 points here, sometimes it's 5. When it's 6 points, they're going to give you a point for just putting the plus c. Okay, and then using the initial condition, so solving for the plus c and doing that correctly gets you another point, and then getting the y by itself.